let's do another example of the properties of a function from a graph. So here is a graph for you, and you can just copy down that graph. The ends go to infinity, so those are arrows, and then it does go through these 3 points that are given, -1, 1, 1, 2, and 3, 0. I'm going to write that one out, 3, 0. All right, now the things we're going to find out about this graph, first of all, we usually want to find the domain and the range. So remember that the domain is the x values, so we want us to go from left to right for x values, just the way you read in English. So over to the left, notice that there's an arrow, so it is going towards -infinity to the left, and then towards the right, it is going on forever, so that is positive infinity. Notice that there's actually no numbers that the x's cannot be. X would be all real numbers. For the range, okay, there is no graph down here. We want to, for range is y values, so we want to start from the bottom and end at the top. So the bottom is right here. This is the lowest point at 3, 0. So the range is the y values. So let's say bracket 0, bracket 0. Bracket because this point is included in the graph. And then obviously we've got arrows on the ends, so we have positive infinity there. All right. Another thing that we might be asked is for some values on the graph. So in this case, you might be asked for such as the f of -1 or the f of 3. So the f of -1 means what is the y value when x is -1? So here is x is -1, and see that the y value is 1. Okay. It is the same as saying the point -1, 1. The f of 3 says when the x value is 3, what is the y value? So that's 3, 0. All right, another thing that we might be looking for is where is the graph increasing? So that's another one of those vocabulary words from section 3.3 that we want to understand. Increasing just means the graph is heading upwards from left to right. Always look from left to right. So let's take a look at this graph from left to right. Notice that this part is going downwards. This part is going upwards. So I'll highlight that because that is increasing. And then finally, this part is going upwards, increasing. And we're always going to answer the x values, and we're going to answer in interval notation. So it's going to be x intervals. Okay? So the graph is increasing, the y values are increasing, but what we answer is where it occurs, which is the x values. All right, so I see it increasing from -1, and then it stops increasing at this top of this hill at 1. Use a union symbol to say it also, that's a union, it's like a U, it means and. It's also increasing here, starting at the x value of 3 and going forever, so that would be infinity. For increasing and then decreasing, we're always going to use parentheses. All right. For D, we have where would the graph be decreasing? So if it's decreasing, it's going downwards, and that is also going to be answered in x intervals. Okay, let me erase the parts that are increasing so we can highlight the parts that are decreasing. So I see it going downhill, decreasing here, and then here again. So we're going to answer those 2 intervals. Notice that it's starting over at -infinity, and it's decreasing until the x value of -1. Union with, it is also decreasing starting here at x equals 1, and it goes downhill until x equals 3. Okay, so just answer the x values. Okay, Two more things we're going to look at are the maxes and the mins. So let's look at the relative minimums first. So this would be called the relative minima. And I don't want you to get confused about the A on the end there. That is literally just the plural of minimum. So minimum, mum, plural, minimums is really the word minima. Okay, so don't think that it's asking for something different. It's just saying for relative minima, there could be multiple minimums on the graph. So to find minimums on the graph, we're going to look at the little valleys, the bottom of hills. Here's one, and here's one, okay? So the relative minima, and then it's the y value. So the relative minima would be y equals 1, and then you say where it occurs, at x equals -1. And the other one, notice that the y value is 0, y equals 0, at x equals 3. Okay. Relative can also be said local. Okay, relative and local just means it's the lowest point to either the left and the right of it. Okay, there's another thing then called the absolute minimum. Absolute minimum. Okay, absolute minimum. There can only be one of those because it means the lowest value of the whole graph. Okay, where is that lowest value of the whole graph? Well, it's just this point right here, right? The lowest value of the whole graph is 0 at x equals 3. Okay, so notice that it is relative, but it is also the very lowest point of the graph. Okay, and then let's talk about the maximums. So G. Let's talk about the relative maxima. Okay, now just like this is a plural, instead of saying maximums, in math we get a little fancy and we say maxima. Okay, that's literally just the plural. So it means there could be more than one relative max. So looking at the graph, let me erase that minimum. Let's see. It would be just a relative top of a hill. See, there's one right there. Just it's lower on both sides. Okay, so that is actually the only one. And that y value is 2 at x equals 1. Okay, there's only one of them. And let's take a look and see, finally then, if there is an absolute maximum. See, that is a singular maximum because there can only be one at the most. Okay, so when we look, is this 2 value the highest the graph goes? Absolutely not, right? So notice that the graph actually goes to infinity, up, up. Okay, absolute and relative maxes and mins are real numbers, so you can just say none. Some people like to write infinity, but technically it means there is no maximum value. It has to be a number. So the true answer really is none. All right.